Hello students, today I am teaching you geometric construction of grade 10. So let us start with the explanation, children. Before starting with the explanation, I'll be taking you towards some of the important concepts. This is a circle. This is a triangle. Triangle is inside the circle, so your circle will become circumcircle. This is one angle, angle BAC. As you can see in the picture, angle BAC. When I will extend this line segment AC and AB, that will become line AC and line AB. This angle which is inside the triangle, but the triangle is there inside the circle, so this angle will be your inscribed angle, which is intercepted in the arc BC. So this is your intercepted arc BC. Now, angle BCA is your inscribed angle and arc BA is your intercepted arc. Now this time your angle ABC is inscribed angle and arc AC is your intercepted arc. Now if I am drawing a line L at point C, my line L touches point C to the circle. So my line L is called as tangent to the circle. Now if you will see line segment AC and line L tangent, both makes an angle at point C. So if you will look at this angle is known as tangent secant angle because it is made between tangent and the secant. Now, if you will see the star mark at the position of angle ACD and angle ABC. So these two angles are equal to each other. Now, if you will see, I am taking you towards the first type of construction. Draw a circle of radius 3.6 cm. Draw a tangent to the circle at any point on it without using the center. So let us have a look at analytical figure. So what is our analytical figure? We need a circle with center O. It can be anything else. We need a tangent to the circle at any point on it. So let us consider any point on a circle M. And this is a tangent L at a point M on it. Now let us have a look at the construction step. First you need to take a center. Then you will measure 3.6 cm from the scale and then you will draw a circle of radius 3.6 cm. So this is a circle. Now you need to draw a tangent to the circle at any point on it. So let us take any point on it, point M. Now after that, basically you will take two more points on the circle and you will join it by line segment to form a triangle. So let us have a look at this step. So this is my triangle. So this is the step where I have drawn the triangle. Now what you need to do is you will have to draw a congruent angle at point M, which should be congruent to angle NLM. So just have a look at the step. You will draw an arc for drawing congruent angle. This is the way you will draw an arc, and the same arc you will draw on line segment NM also. Now you will just measure the distance between PQ, arc PQ, and that same distance you will cut from point R. I hope you all are getting this step. And then you will name it as point S, and then you will join it by line segment. So here is my tangent which is drawn at point M. And here I have not used center to draw this tangent. Just for the sake of understanding, you will draw a radius 3.6 centimeter. And you will name it as 3. You will just write the measurement of that radius. So this is my tangent which I have drawn it without using the center. Now let us have a look at the next type of question. Draw any circle, take any point A on it, and construct tangent at A without using the center of the circle. Now this construction is similar to the first one. What is the difference over here, children? In the earlier construction, measurement of radius was given. Over here, measurement of radius is not given. So the step of construction will remain same. Only thing is that we can choose any radius to draw a circle. Rest all steps will be similar to the previous one. So let us have a look at the analytical figure first. Circle with center O, point A, tangent L. So now we will start drawing our construction. You will measure any radius, you will take any radius and you will draw circle. Then the next step will be you will take point A, and as I have told you earlier, you will have to take 2 more points on the circle. So 2 more points on the circle, then you will have to join it by line segment. So this is, I am drawing it by the line segment to form a triangle which is inside the circle. Now, as I have told you, you will have to draw a tangent at point A, so you will have to draw a congruent angle. So first you will draw arc, then with that same arc you will cut it on line segment AC as well. Then you will measure the distance between PQ, this is the way, and that same arc you will cut it from point R also. This is my point S. Then you will join A and S. So this is my tangent L, and my tangent L is drawn without using the center of the circle. Now let us have a look at another type of construction, children. Draw perpendicular bisector of segment of length 5.5 centimeter. So what is the step? First you will draw a line, then you will take 5.5 centimeter line segment just by drawing an arc on this line. So this particular distance between point AB is my line segment AB, which is of length 5.5 centimeter. You will take more than half of this line segment. Then you will draw an arc from point A up and down. Then you will draw an arc from point B up and down. You will name it as X and Y. Then you will join it by line. This line is my perpendicular bisector of line segment AB. You will name it as line L, and here you will make perpendicular sign, and since it is bisector, so this both will be equal to each other. Now my next construction is draw a circle with center O and radius 3.5 cm. Take point P at a distance 5.7 cm from the center. Draw tangents to the circle from point P. So this is my analytical figure. You need to draw a tangent from a point which is outside the circle. So this is my analytical figure, rough figure. O and then P, which is at a distance of 5.7 cm from point O, and two tangents PA and PB, which is drawn from point P. And this is my radius OA and radius OB. Since you know the property that tangent and radius are perpendicular to each other, so you can see that perpendicular sign near OA and near OB. So let us have a look at the fair figure. Center O, 3.5 cm radius. We will measure it from the scale. Circle is drawn. Then randomly you will just draw a line. Then you will measure 5.7 cm from the scale, and you will keep your rounder point on at point O, and you will cut an arc and you will name it as point P. So my distance between OP is 5.67 cm. So this is my distance between O and P. Now I have my point P outside the circle, and I have to draw a tangent to the circle from point P. So let us have a look at the steps. What I will do is I will take more than half of OP and I will draw an arc from point O, and I will draw an arc from point P. So this is two arcs which I have drawn it by taking more than half of line segment OP. I will name it as XY and I will join it by line. So this I have drawn it. I have joined it by line, and I have given this line a name as line L. Now what I will do is I will measure the distance between M and O, and I will take OM as a radius, and I will have an M as a center, and I will have to draw a circle. Remember, OM as radius, M as center. So this is the circle I have drawn. Now if you will see, my previous circle with center O and my other circle with center M both are cutting each other at point A and B. So what I will do is I will join it with point P to A also and to B also, and I will join OA also, and I will join OB also. So here my O and OB are radius, which was 3.5 centimeter, and my PA and PB are tangent, and as I have told you that radius